lecture per week, and 1 hour will be reserved for tutorial. In this tutorial, we'll solve some problems together. Sometimes I will ask you to solve, because in the current mode of teaching, there's supposed to be continuous evaluations. So in that way, I'll give you assignment, you'll have to solve. In the class, of course, we'll have some interaction, and not always, but during the tutorial hours, I interact with you more. So 2 or 3 will try to evaluate. Mid-semester, there is nothing like mid-semester, end semester as you used to have earlier. So it's a continuous start there. I'll notify the dates of examination, dates of test earlier, much earlier, and then we'll use that. Textbooks, the name of the textbooks, I'll tell you in 1 or 2 days. There is one book. Actually, I should give you something. A list of textbooks in the kind of what file or PDF form. But one textbook is useful and it has many solved examples. This is by S.S. Rao. There is a book by Professor Rao, S.S. Rao, Mechanical Vibration. There is a good book by Meyrovich. I'll give you the names written. Meyrovich. There is a book by Thompson, and there are many other books. Okay. But the main thing is that all of the books, they consider the linear vibration mostly, although they also refer to nonlinear vibrations. But in coming classes, I'll try to give you an overall idea of vibration, that is different kinds of vibratory system. Right now, when I asked you what is vibration, you always talked about the small amplitude or spring mass system. There has to be spring. Of course, this is very normal because you are not exposed to different kinds of vibratory system, okay, which is capable of vibration. Now, in the coming classes, I'll let you know, I'll teach you the classification, different types of vibratory system, where you will be amazed that these things are also called vibratory system. It's not a mechanical vibration just like spring mass system, but this is capable of vibrating. And vibration does not always mean that the amplitude will be small. Vibration also can happen with a large amplitude motion. It's very much possible. We call this as a nonlinear vibration, vibratory system. What you have learned in your undergraduate or up to now is the linear vibration. That means we have always assumed that the amplitude of vibration is very small and approximated to the equation, correct real equation of motion to simplify a linear equation of motion. But this may not be always possible. And when you see that amplitude of motion can increase very easily. One example is that you have definitely come across the term resonance. Have you heard the term resonance?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
What is resonance?
Yes,
What is resonance, by the way?
When the amplitude of vibration is equal to the natural frequency of the system.
Amplitude cannot be equal to natural
Sorry. When the frequency of vibration.
So there is a forcing function, right? Forcing, again, a periodic forcing function, and this period will be same as the natural time period.
Yes.
What will happen then?
Sir, amplitude increases, sir.
Amplitude will increase.
Yes, sir.
How long? How much?
To infinite.
It will go to infinity. At one
Sir,
point, you are saying in the linear vibration, you are saying that there exists a phenomena. There is a phenomena where the amplitude is going to increase to infinity. But while deriving the equation of motion, you assume that the amplitude is very small. So don't you think there is a kind of inconsistency? You derive the equation assuming that the amplitude is very small.
Sir, sir, in force vibration, as soon as we start supplying energy, and thus the body start consuming that energy, and it is not able to dissipate that energy, and this energy is storing and goes on storing inside the body, and thus the frequency, thus the amplitude of the body.
Yes, I understand. You are explaining the mechanism of, I mean, the reason why the amplitude goes on increasing. My question is different. You try to understand.
Yes,
My question is that you are saying that vibration means always small amplitude oscillation, right? On small amplitude motion, you said.
Yes.
Okay. Now, when you describe resonance, you are saying that the amplitude goes on infinity. Amplitude keeps on increasing. So don't you think there is a kind of inconsistency in these two things? That is, you initially assume that amplitude should not be large, but at the same time you are saying amplitude goes on infinity.
Sir, I think that assumption is only
Yes,
for
sir, both are
mathematical
Right. So therefore, so what you say is that the amplitude is small. This is not valid everywhere. Even in the linear vibration, you are saying many things using your equations of motion to derive certain phenomena like resonance and anything. But this really physically cannot happen because the amplitude, I mean, physically resonance happens, but you cannot explain with the help of linear vibration theory because linear vibration is not valid in this region, right? When the resonance is taking place. All other nonlinear terms which you have neglected so far, those will be important because the amplitude is now high. Am I clear?
Yes, sir. Thank you, sir.
Yes, sir.
Also there are certain things which you do not consider, but this you have to consider if you have to analyze the situation truly. That is, you have considered the forcing, right? Forcing some thing which applies the force. So you said the increasing during resonance, isn't it? Yes, you said, right? Energy, and this is correct. The energy keeps on increasing, so therefore the amplitude keeps on increasing. That's perfect. Okay. But where from this energy is coming? Where from the energy is coming?
External force.
External force. So there will be some machine which will provide the external force, and energy will come from that machine, right? So as the amplitude is increasing unlimitedly, so therefore without any bound, so the energy has to come from the source by the same amount, because the body cannot generate energy on its own, so therefore energy has to come from the source, right? Now, if you draw, if you take out infinite energy from the source, right? So what will happen to the source? Will it work?
No, sir.
It will work only if you consider the source to be kind of energy reservoir of infinite energy. Just like in the thermodynamics, you had a thermal reservoir, which where the temperature did not change even if you took out the.
Yes, sir.
Okay.
So the same thing is going on with the voice.
That source has to have infinite energy.
Sir, we can't hear you.
And even if you draw out infinite,
And same thing is going on.
with the same equations, etc., but those are physically, they cannot happen because there are certain something is going on. Yeah, please again repeat. His voice broke in between.
Sir, your voice is lagging and breaking also. Hello.
Sir, what have you discussed in last 2-3
You
minutes?
said the same thing is going on in.
Sir, what you have discussed last 2 or 3 minutes, we didn't get for
Vivek,
Yes, sir.
Actually, voice is not clear, sir. It's breaking and slugging also.
Okay. Maybe trying to say something, but I here. Again, the same thing.
Yes, sir. Yes, sir.
Again,
Same
it is
thing.
breaking.
Yes, sir.
It's also breaking now. Can you hear me?
Now fine, sir.
That's fine. Okay. So what I was saying is that if you have a vibratory system which is undergoing resonance, then its energy is going to increase with time. Right? And the energy, it increases. This energy comes from the source of vibration. That is a source of excitation. And this is actually a physical system. It is providing the energy which is flowing into the vibratory system and increasing its energy. But what I say is that in this particular process, infinite amount of energy will be drawn out of the source and it will go into the system. Now, physical system will not be able to sustain this kind of situation. That is, the energy, infinite energy is taken out of the system, but still the energy remains so high that it is exciting the body. So there is a mismatch. There is saying that infinite energy is drawn, but no physical system will be able to give infinite amount of energy. So always there will be certain problems, and if you do not have a broad overview of the vibratory vibration, if you think that vibration means only linear vibration, or vibration means only a motion with small amplitude, then most of the phenomena you cannot predict, you cannot solve, you cannot analyze with the equations of motions which you derive, because your assumptions are not correct. So for that reason you have to know what are the different types of vibrating system, and this we will learn in coming classes. Next class, of course, I'll teach you how to derive the equations of motion. So there has to be a systematic way, because the equations of motion is the most important thing. And this equation of motion, if the equations of motion are derived wrongly, then all the analysis will be wrong, as is very simple to understand, because whatever is based upon a wrong thing has to be wrong. So first of all, we have to learn how to derive the equations of motion. And then we'll use these equations to see what are the different types of vibrating system. And after that, knowing that what are the different types of having a full picture of the vibration, we'll restrict ourselves to a very small domain, the domain where the vibration amplitude is very small and the linear vibration analysis result is valid. Okay, that will be our approach. Okay. So in the next class, we'll learn how to derive the equations of motion. Right?
Okay, sir.
Okay, sir.
Good.
The book by S.S. Rao will be okay.
Book by S.S. Rao will be good enough. Yeah, but most important is that because these books, normally books that are written with a very specific objective. S.S. Rao book will be, from the very beginning, it will be linear analysis, but we'll see many things which are not there in S.S. Rao's books, in no book at all, because what I'll teach is most of them are coming from my own experience, so therefore they may not be available in a book. So you please better be attentive in the class. I'll give you my lecture notes from time to time if when I'm ready with them. Okay, so lecture notes you follow. You can of course record my lectures in the MS Teams and circulate it or look at it later on. But the lecture notes are more, lectures are very useful. So books will be there, you use that. But mostly that will be that will be helping tools for solving problems. But in lectures, you will learn many things which are not present in the customary or the regular textbooks. Okay, but S.S. Rao's book is a very good book. You can refer to them. Refer to that. Okay.
Okay, sir. Thank you. Okay, sir.
So, Tika, I think for the first class, we have already spent 1.5 hours. This is a little too long for the first period, for the first lecture. So let us now slowly leave. Okay. Have a good day.
Excuse me, sir.
Yes, yes.
Sir, can you please report about the tutorials and exams? There is some disturbance during.
Please, what do I say? What do I do?
Can you please repeat about that tutorials and exams?
Okay. Tutorials. What I say that this Tuesday, Wednesday 9 to 10. This hour, this time, I may not take regular lecture. Sometimes I may take, but mostly I will not take this for regular lecture. So what I'll do, I'll give you the problems, tutorial problems to solve in the class. My students will be there. I shall be there. I'll help you. Okay, we'll solve together some problems. Sometimes I'll ask you to solve independently and show me the result. Mostly this will be kind of interactive session. Examinations, and as I said that the evaluation will be now continuous evaluation. Earlier, those of you who are dual degree students, they remember, of course, as long back, one or 2 years back. So we used to have midterm examination and end semester examination, and there is to be a kind of teacher's assessment consisting of 20 marks. But now those are not there. There will be continuous evaluation. So we'll take test 2-3 times text, and I'll send you the question link. You solve conveniently, and then upload the link, upload the PDF file in particular link, or here itself in MS Teams within the stipulated times, and we'll evaluate them. So based on this kind of evaluation, I'll be able to evaluate your final, give you final grading. Okay, so that is what I said. So tutorial classes, this Wednesday from 9 to 10 will be reserved for tutorial. This time I will not take any lecture. That's what I said.
Sir, can I access the? Hello, sir.
Can I?
Can I access the question link with a mobile, with my mobile, because I don't have laptop right now?
Right. No, I'm not giving any link right now. I'll give you link, and if you have mobile, definitely, if you can open MS Teams, so therefore it will be given in the Teams itself. So in the MS Teams, you will get the question paper, right? And you download it, you solve wherever you feel like, and then upload it as a PDF document in the same MS Teams. There will be provisions.
How much time you will give for solving a question?
That depends. Some test will be 2 hours duration, some test will be 1 hour duration, some test will maybe of 15 minutes or 30 minutes duration. That will depend. Okay.
So is there any book for problem solving, sir?
All the engineering vibration books have number of problems solved. Like as you were saying, S.S. Rao's book, it has number of problems. You can solve them. There is a book. It's called Mechanical Vibration in SHAUM series, SHAUM's outline series, SHAUM, SHAUM series, and there are many solved examples. SHAUM's outline series, vibration. Okay, many solved examples are there. So we'll definitely solve problems in the class also. I'll give you tutorial, the assignment you have to solve and then submit. Okay. So likewise, we'll learn together solving different problems, different kinds of problems, solving different manners. Okay. But mostly, more than solving problems, don't take this class as a class for solving problems. Okay, problems you'll have to solve. But first of all, you'll have to understand. So solving problem is one thing, but solving it accurately with full understanding is a different thing. So here I urge or I suggest that be attentive in the class and try to understand the things rather than solving problems all the time. Okay, solving problems, of course, is one very important aspect in the from the examination point of view, but you have to learn what are there in mechanical vibration. Okay, there are many aspects of vibration. You'll be so vibration is actually such a broad field that most things are capable of vibration. Okay, so vibration is a big field, huge field. So you will try to learn some of it, a little small portion of this particular big field, but in a systematic way. And you will have to learn where are the loopholes, where are the drawbacks of the current model. All these things you have to learn accurately or learn well, so that you can apply your knowledge in the real engineering problem which you will solve in later time. Okay, textbook problems are one kind of problem, but the real engineering problems is a different kind of problem. I suggest that you learn in such a way that you will be able to solve the real engineering problem. Okay, but textbook problems are definitely needed. For that, you can refer to Professor Rao's book. And some problems I'll give as a tutorial problem also. है ना?
Okay, sir.
Okay. ठीक है. Okay, so if you do you have any question? Any further question?
No, sir.
No, sir.
Okay. Then if you do not have, then let us call it a day.
Yes, sir.
Okay.
Thank you.
Goodbye then.
Thank you.
Thank you, sir.
Welcome. Goodbye. I'm leaving.
Thank you, sir.